Hello, my dear children, and welcome back. I know, exams are just around the corner, and that chapter on sorting algorithms can feel a bit tricky. But don't you worry one bit. In the next few minutes, we're going to make this topic so easy, you'll be explaining it to your friends. Cello, let's get started. Just think about it for a second. You need to find your friend Rohan's number on your phone. Boom. It's there in a flash, right? That's because all your contacts are sorted alphabetically. But what about finding your favorite blue t-shirt in a cupboard that's a total mess? That's a whole adventure. That right there is the simple, amazing power of arranging things, or what we call sorting in the world of computers. Isn't that just mind-blowing? The phone that you hold in your hand is basically a supercomputer compared to what NASA used to send people to the moon. But all that power is nothing without smart instructions. It's these clever techniques, these sorting algorithms, that really make our devices feel so fast and magical. So here's our plan for today. First, we'll understand what sorting actually is. Then, we'll look at three main types: bubble sort, selection sort, and insertion sort. After that, we'll figure out which one is the fastest, and finally, we'll do a quick revision just for your exams. Ready? Cello, let's dive in. So, first things first, what exactly is sorting? Well, at its heart, it's just about putting things in a proper order. Like numbers from smallest to largest, or all the names in your class register from A to Z. And why do we do it? Simple, to make finding anything super fast. Now, this is the formal definition you'll find in your textbook. But forget the big words for a moment. Just imagine you're going into an exam hall. All the roll numbers are arranged in order, right? So the teacher can find your seat in seconds. That's sorting in real life. We're just teaching our computers how to do the exact same thing. Okay, our first method is bubble sort. And trust me, it's the simplest one to get. I want you to imagine a glass of soda. The heavy sugar will sink to the bottom, and the light bubbles will float up to the top. Bubble sort kind of works like that. The logic is really simple. The computer looks at two items that are right next to each other, like two best friends. It asks, hey, is the number on the left bigger than the one on the right? If the answer is yes, they just swap places. And it does this again and again for the whole list. After one full round, which we call a pass, the biggest, heaviest number has bubbled up to its correct spot at the very end of the list. Let's actually see it happen. Look at this list. We start at the very beginning. First, we compare 8 and its neighbor, 7. Is 8 bigger than 7? Yes, it is. So, poof, we swap them. See? Easy peasy. Okay, what's next? Now we compare the new 8 with 13. Is 8 bigger than 13? Nope. So we don't do anything, we just move on. The computer keeps doing this all the way to the end, and look what happens. After that first full pass, the biggest number 13 is perfectly sitting at the end where it belongs. It's sorted. Now, for the next pass, we do the exact same thing again, but here's the smart part. We can completely ignore the number 13 because we know it's already in the right place. So with every pass, the list we have to check gets a little smaller, and our sorted section, which you can see in green, keeps growing from the right side. Okay, time for a quick question for all you smart kids, and this is straight from your textbook. What if you wanted to sort the list the other way around, from biggest to smallest? What tiny change would you make to the computer's logic? Just think for a second. Got it? It's so simple. Instead of swapping when the left number is greater than the right one, you just flip the logic. You swap when the left one is less than the right one. You just change the greater than sign to a less than sign. That's it. Such an easy way to score marks in the exam, beta. All right, on to our next method, selection sort. Now this one's got a completely different strategy. It doesn't compare neighbors. Instead, its mission is find the absolute smallest element in the entire list and put it right at the beginning where it belongs. So let's look at our list again. In its first pass, selection sort scans the whole list from start to finish on a mission to find the one single smallest value. And in this example, as you can see, the smallest number is -9. So after all that searching, once it's found the minimum value, -9, it does just one single powerful swap. It takes that -9 and swaps it with whatever is sitting in the very first position, in this case, the number 8. And just like that, after one pass, the smallest element is perfectly placed at the beginning. Now for the second pass, we can ignore the -9. It's sorted. We just look at the rest of the list. We find the next smallest number, which is 1, and we swap it into the second position. So, you see, with selection sort, the sorted part of our list grows from the left side. And now for our final method, insertion sort. This one is super easy to understand, especially if you've ever played cards like Rummy or Uno. Imagine you're getting cards one by one. You pick up a new card, and you immediately slide it into the correct place in your hand, right? That is exactly how insertion sort works. Let's just imagine there's a little wall on our list. Everything to the left of the wall is already sorted and neat. Everything to the right is still unsorted and messy. We start by assuming that the very first number is our tiny little sorted section. Then, we pick the first card from the unsorted pile, which is the number 7. Now, we take that 7 and we ask, where does this belong in our sorted section? Well, 7 is smaller than 8, so we have to make space for it. We shift the 8 to the right, and we slide the 7 right into that empty spot. Now our sorted part is 7, 8, and we just keep doing this, picking one element at a time and inserting it correctly. So we have 3 different ways to sort a list. But which one is the fastest? Which one is the best? Because in the real world, when companies are sorting lakhs and lakhs of items, speed is everything. And to measure this speed, we use a concept called time complexity. But before we talk about speed, let's just quickly look at this table. It's a great summary. Bubble sort is all about comparing neighbors. Selection sort is about finding the minimum and swapping it to the front. And insertion sort is about picking one element and inserting it into the sorted part. This is perfect for a last-minute revision. Okay, now this is the most important thing you need to remember for your exam, so listen carefully. All 3 of these algorithms, bubble, selection, and insertion, have something called a time complexity of n squared. Now that sounds very technical, I know, but all it means is that they get slow very, very quickly. If you have a list with 10 numbers, they might sort it in 1 second. But if you have 100 numbers, they won't take 10 seconds. They'll take over a minute. And if you try to sort a list with a lack of items, oh my God, you can go have your lunch and come back and it might still be running. They're just not built for big, big lists. All right, we've made it to the end, so let's do a final super fast revision to lock all these ideas in your brain so you're perfectly ready for your exam. Everything you need to know, all in one place. Let's go. Remember these keywords. Sorting is just arranging things in order. Bubble sort compares adjacent elements, the ones next to each other. Selection sort selects the smallest one from the whole list. Insertion sort picks an element and inserts it, just like playing cards. And for all 3, the complexity is n squared, also called quadratic time. This means they are fine for small lists, but for really big lists, they are just too slow. And that's it. See? Sorting algorithms are not that difficult after all, are they? You have understood the main idea behind 3 very important algorithms today. Just go over these points one more time, and you will do wonderfully in your exams. You've got this, Betta. Best of luck.